Alright, so in the last class we have talked about the object code. So at this point, what do we know? We don't understand the instruction yet, but given any instruction, we can identify their object code. We can identify their addressing mode, and also we can write the object code. So we can basically translate those instructions into machine code, right? Though we don't understand, we don't even understand their purpose, why they are written, we don't understand anything. So today we will make our first effort tonight to understand the instruction a little bit. Remember, we cannot understand everything at one point at once, so this is the first step. So we'll probably understand a little bit of one kind of instruction after tonight. Now at this point we just know these. Let's say these are the instructions given. Let me show you another slide. It's a little bit more exciting. So these are the instructions, and we know that they have object codes. We know exactly how to find the object codes, and we know that some of the object codes are 1 byte, some of those are 2 bytes, some of those are 3 bytes, right? So and exactly you see here how those instructions are allocating the memory locations. For an example here, look at the first one. Let's say if we assume that the instructions instruction has started being stored starting from location 0000, which is the first byte in the memory location, right? So let's say the first instruction is taking 2 bytes here, right? 96 and 10. So automatically the next instruction will be starting from 2. Do you see that? So this is basically your 0000 byte. The next one is basically your 0001. So this is 0002. So this is 3, this is 4, 5, 6, and that's 7. So that's how we understand that how the instructions are basically allocating the memory bytes. But remember that in reality the memory location will not be starting from 0000. This is just a sample example to understand. But we know exactly how that will be allocating the space. So this is exactly what we know at this point. We don't even understand what the source code they mean exactly. So today we'll first try to make our first attempt to understand it a little bit more than what we know. So far we know the addressing mode. So from the instruction we identify their addressing mode. But what the addressing mode really tells us, we don't know it yet. So let's see here. First of all, any instruction has 2 parts, we know that. One is opcode and other one is operand, right? Now the operand can be 2 different types here. The operand can be either a data itself or it can be an address. Okay? It can be a data or it can be an address, and exactly the addressing mode tells us whether that is a data or that is an address, because at the end you are writing everything in hex. So just by looking at those you don't know exactly which one is data and which one is address, unless one little difference, because most of the data are 1 byte itself, but you can play around with 2 bytes. So that also will not work, because addresses are 2 byte, data can be also 2 byte, data can be 1 byte, right? But now you see from here what exactly addressing mode will tell you about the operand. So at this point we know that can be either address or data. If you look at here, the immediate, in case of the immediate, the operand is always data. Operand is always a data. It's not an address. So doesn't matter how long it is, it may be 1 byte or 2 byte, because you have seen when you generated the object code, some of the instruction has 2 byte of operand, right? Sometimes it's 1 byte. In case of immediate, right? Doesn't matter it's 1 byte or 2 byte, it's always data. Direct and extended, they're always address. See, at this point the number system doesn't matter. Maybe it's immediate, maybe it's decimal or written in binary, in hex. We always write it in hex, but in computer everything is represented in binary. We write it in hex because hex is little bit compact. Instead of writing a longer number, you can write it in small. So that's why you probably prefer hex, but doesn't matter, because you saw remember in the addressing mode questions, even in the object code question, you have seen that we can even if we prefer hex, we still can write the data in decimal, in binary, using those percentage sign, using no prefix, we can write decimal, right? So, that technically this doesn't make any difference, and in case of inherent here, there is no operand, so there is no issue of such data or address. So now we know that immediate means your operand is a data. Direct or extended means your operand is an address. Now, in case of direct, the address is written in 1 byte. In case of extended, the address is written in 2 byte. Now we might wonder, because you know that the address is 2 byte. Remember, it's a 16 lines of address, right? When you saw the architecture little bit, you probably remember it's 16 lines. So how you are going to write it in 1 byte? But now remember, you can, for an example, your address is, let's say, 005A. Now instead of writing 005A, you can always write 5A. So in those cases, the addressing mode is direct, because you can write the 16-bit address, but you can write it only 1 byte. I'm saying whenever it is 005A, instead of writing 005A, you can just write 5A. So that's the same thing for us, right? That's the only difference. But technically, the address lines are still 16-bit, because whenever you are writing 5A, it's assuming you are writing 005A in case of direct. Now, tonight we'll try to understand one specific type of instruction. Those are called load instructions. Now, these instructions are so vital, I think we cannot even imagine a single program of microprocessor class or any assembly code without loading, because all it does is it basically loads the data from memory location to register. Remember, as I mentioned in our previous classes, that we always do the operation in registers, right? So before you do the operation, you have to load it from the memory location, right? Then probably you will either add, subtract, or again, remember the subtract is 2's complement addition, so because the computer cannot do anything. So all these 5 instructions, all these are load instructions, but they load into different registers, since we have several registers, right? Remember, we have accumulators, we have index register, stack pointer, and some other register as well. But remember, we don't understand the purpose yet. So if you don't understand what are the purpose of register, that's fine, because we don't understand it yet. But we know something about those. We know that accumulator A and B, those are 1 byte each, right? Accumulator, other registers, all of those are 2 bytes. And there is a little bit something missing. I'll probably add it in the slide before I upload it tonight, which is there is a register called D, okay? There is no physical existence of that register. Physically, that register do not exist, okay? But what happens is, whenever you are trying to do operation with D, it basically combines A followed by B. So basically, anytime you refer D, that means A, B together. It's 2 byte, okay? But A following the B. So the higher byte is A, lower byte is B. And also there is a load instruction for that as well. That is called LDDD, because the way those are written, okay? I'm sorry, LDD, load data into accumulator D. That's how we try to read those. Now let's look at a little bit more detail at how those are loading the instructions. So remember, anytime loading means you are basically transferring the data from memory to register. That's all it's about. But remember, since we have different registers, so we need different instruction for those. Now let's see. Let's look at an example. Okay, now we have an example here. LDAA #177. Now first of all, by the description we know that this is a load instruction which loads the data into accumulator A. Now first of all, can you tell me whether this is a data or an address? What is the addressing mode? It's immediate, right? Remember, the immediate is always data. So this is a data, which is 177 in what number system? Any doubt? It's decimal, right? Because there is no pound sign, and it's not binary because it's 7, there is a 7. So this is data. Good. Now what is the next step? Once you write it, automatically this data is going to be, anytime, remember, we are always working with the data. So the data is going to be loaded into accumulator A. Now look at the data, is B1. Why? We just converted 177 into hex. Because we always try to write it in hex. So that's how we, but remember, again, as I mention every time, I'm again mentioning, in computer, everything is in binary. Okay? So the B1 is still, you can write B1 in binary, right? Which will be 1011 and 0001. However, you just write binary. Let's look at another example. So, if somebody asks you a question that what data is going to be loaded into accumulator A by this instruction, the answer is B1. I'm saying we always give the answer in hex, so that's why the answer is B1. Let's look at another example. So we just have the same example, but except the pound sign. What is 177 here? Data or address? This time this is an address, because there is no pound sign and this is not, this is, what is the addressing mode? Direct, extended? It's direct because it's 2 byte, and LDAB has direct mode, because we know that some of the instructions do not have direct mode, so that's for those we always consider extended, right? So this is an address, so we know that. Now what is going to, so we know that by the instruction we are loading into where? Accumulator B. What is going to be loaded? This is an interesting question, because we don't have data yet, because this is an address. In the last one, we had the data right away in the instruction. Now, we have an address. So what we need is this. We don't know yet. We need this. What is this? This is the memory map. Okay? Let's say I gave it to you. I said, this is what we have in the memory, computer memory. Okay? This is not the whole map. This is a snapshot of, little bit. So how do we read it? If you look at here, in the left side, this is the address. Okay? In the very left side of this left column, let's say this is an address. Okay? Can you see my mouse? Okay. Now, this is basically the address 10. This is 11. You see what I'm saying? This is 12, 13, 14, 15, 16, 17, 18, 19, and what is this? 19, and what is next? 1A is in hex. After 19, next number is 1A, right? So the next one is, so this is, oops, we lost the mouse. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 1A, then it's 1B, 1C, 1D, 1E, 1F. And then after 1F, the next one will be 20, which is here again. So, in one row, we are basically covering all the 16 numbers for that 10. It says 16s because, these are in hex. Now, can you find here which is B1? What is B1? I marked it, right? Do you see the B1 here? 2D. This is your B0, right? This is what I'm saying? This is the starting one, it's the B0. Automatically the next one is B1, B2. So this is B0. So by that instruction, this is going to be loaded. Because that's an address, and you are looking for the data in that address, and you know exactly what is the data there, which is 2D. Any question here? Anytime you have an address, you have to look at the memory map. Now remember, we'll do some quiz tonight for this part. In all the question, you will be given memory map, but sometime you will need it, sometime you will not, based on the instruction. Okay? If it is immediate, don't look at memory map, because immediate you always have the data, right, in the instruction. If it is not immediate, you have to look at here to find the data. Okay? And for an example, for this question, let's say if I give you this instruction and I tell you what data is going to be loaded into accumulator B, your answer should be 2D. You see what I'm saying? Just write 2D. Now, couple of more things. We just shown you two examples of A and B, right? But what happens if in case of other registers, because remember all the other registers are 2 byte. So you'll be loading 2 byte. Now in case of this situation, let's say if this is, let's say X, LDX, you know the index register X is 2 byte. And basically all the registers are 2 byte except A and B. So and let's say the address is B1. So what do? This is B1. You will take that byte and you will take the next byte. So the data going to be loaded is 2D40 because you will need 2 byte. You see what I'm saying? Because you always take that byte, next byte. That's how you will get 2 byte. But we'll do a lot of practice. You know, there are several variations because we make sure that you understand how the data is loaded and exactly what is loaded. And remember, this class is so important in following the sequence of quizzes. If you don't follow anything, you will run into trouble somewhere. Because you know now you see here, understanding of instruction mode is addressing mode is so important here. Okay, understanding of object code is also important. Once after a couple of things, you will see everything what you are learning in different places will be extremely significant. If you don't understand, you run into a problem. So make sure you get 100% in every single quiz. I know that you see the next one once you see 65. But make sure you do it. So this is the quiz number 3. Since most of you are done with quiz 2, you can see quiz 3 and just go there and start the quiz and answer the questions. So all the questions will be like this. You will be given one instruction and you have to tell us what data is going to be loaded. And remember, except A and B, everything else there are 2 byte. And also one more thing, in case of D, 2 bytes are A and B, okay? If we load data into D, that means we are loading A and B. You see what I'm saying? Because the D, there is no physical existence of D. D is nothing but A and B. But A followed by B. Okay? Let's go ahead with the quiz. I think that will help you to understand and clear all those confusion. Any question? Everyone see quiz 3? So make sure make sure you finish the earlier one so that you can see the quiz 3 as soon as you can, because the more you wait, it will be more hard for you.